Hello everyone, this is Wise with another video of mine here discussing VORs today. Who's excited for that? So VORs, we have three type of VORs, and we're gonna discuss limitations and VOR receiver checks and uh, sign-offs. Um, Basically, track and intercept radials and bearing inbound. So making it very easy for you. First of all, we have to know what VOR stands for. VOR is very high omnidirectional range, uh, very high frequency, okay, which is VHF frequency. And VOR, it's basically a station, like circle station right above ground that spits 360-degree radials, and they spit out um, uh, like slant range. They go like they don't go over the ground straight. To they expand up to 1,000. They go up to 1,000 feet AGL, and then they cover the whole radius that they're supposed to cover. But below 1,000 AGL, if you're somewhere around here, you probably won't be able to receive the signal and tune and IDing it. So watch out for that. That's your VOR. And let's say we have limitations that VOR go crazy sometimes, times. So we know that if your VOR is right up here, for example, you come bearing inbound and you cross VOR, that at this point right up here, it goes. It's called area of cone of confusion here. It's called cone of confusion or area of ambiguity. That's where your nav indicator will go crazy at this point. So that CDI needle will move all the way to the left and move all the way to the right. And your to and from indication goes to off mode and then goes to from indication, showing from indication. So that's your number one limitation. Um, we have three limitations here. One of them is cone of confusion. Second one, reverse sensing. That reverse sensing, basically, if you have a lot of people confuse that. If you are inbound on this radial, right, in this radial of two, let's say, um, say 200, and you have on OBS 200, and you are, it's like that. That's where that's when you're supposed to go ahead and not chase the needle, but go away from it, like heading wise, in order for you to catch the needle. Only when you radial inbound, okay? That's when the VR go crazy on you, and that's not the right way flying it, okay? So be careful on that. And then the third one is VOR should be it is line of sight here. So for example, you have VOR right up here, and it spits like that. And let's say you have a mountain around here that goes like that high. Okay, you have a mountain there, and let's say that signal won't go through. Only that radial probably not gonna go through. But other radials will. So if your aircraft is little chicken here, if your aircraft's around here, then you probably won't be able to catch that signal because it needs line of sight. So, all right, so those are three limitations that VOR has. We're gonna talk about how to check VORs. We have a couple of ways to do that. It's VOT station over the ground. It's plus minus 4 degrees, and you have to find it. Find the station in AF/D, which is chart supplement, and it should give you the frequency, and you should uh, twist the OBS to 180, 1802 or 360 from. Okay, and then make sure you check should be plus minus 4 degrees. That's your VOT station. Obviously, we're gonna tune an ID. Alright, so repair. The second one, number one is that. Number two, we got repair station. Obviously, this goes by the A&P mechanics. They do that. Should be plus minus 4 for them. And third one, VOR airborne check. It should be plus minus 6 degrees. You just get on the radial and for a certain location, and you check your VOR. Alright, and then dual VOR check. Should be plus minus 4 degrees. And that is the most correct one is VOT station. And then usually, if you're a VOR really close to your airport, you probably could do dual VOR checks. And then what do you need to make sure you sign off for it is it's called acronym DIPS, date, error, place, signature, right? That's what you need to once you check it. That's what you have to have written down on a paper or somewhere. Maintenance logs. Okay, that's your checks, and then we go back to VOR here. Let's see. The frequency that we talked about it is 108.0 to 117.95. That's the megahertz VHF, okay, frequency. And the full scale deflection is basically 5 on each side here, these dots. So it's going to be 10 degrees. 2 degrees, 4, 6, 8, 10. So each one of these dots are 2 degrees. Okay. Now let's go back. Go back to see how many types of. So we said 3 types of VOR. We have one of them is terminal. So terminal. Sorry, this pencil doesn't work properly. So terminal VOR goes from the surface, goes up all the way to 1,000 feet AGL, obviously. And then from there it goes up to 12,000 feet. 12,000 feet. This is terminal. So terminal, it's mostly like closer to biggest airports. You can get this terminal. The radius from the center is 25 nautical mile. And this is terminal. As I said, if you're somewhere around here with your little aircraft, you won't be able to reach the signal. So keep that in mind. Now we go to low VOR. And where actually you can find all these different types of VORs is chart supplement. Okay, so it says low VOR. So same thing basically over the station ground. Over the ground against station, there we go. Expands to 1,000 feet, and then that goes up to 18,000 feet. Okay, 18,000 feet, and then radius is 40 nautical mile wide. Okay, that's your low VOR. And excuse me, and the high VOR is from the surface. This one a little bit, you have to work hard on this to memorize it, but it's no big deal. Goes up to 1,000 feet. From there, it goes all the way to all the way up. Let me draw it here right quick before I do anything. Okay, so it goes up to 14,500 feet, and then from 14,500 feet goes up to 18,000 feet, 18,000 to 45,000 feet, and then goes up to 60,000 feet. Okay, so and then we take a look at the radiuses here. Is 40 nautical mile, and we have 100 nautical mile. Expands more up to 130 nautical mile. Oops, there you go. And then goes up to 100 back, shrinks up back to 100 nautical mile wide. So that's your high VOR. It is very goes really high. So since we reviewed VORs and everything about it, now we're gonna review how to properly track and intercept radial outbound. Okay, so we're gonna track and intercept radial outbound, for example. So let's say first of all we have to know. I'm gonna draw the um, what is it? What does radial means? What bearing means? And reverse sensing. How does it happen? So let's say that we have a viewer in the middle here. Let's say it's a DME, whatever, and that spits right there radial out. Okay, so now your aircraft, for example, your aircraft showing that you're going this way. That means you, let's make this 090, let's make 270. Alright, so at this point, this aircraft is on the radial of 090. Well, if we would have turned around, same radial, that would have been bearing inbound to the station, bearing to the station. So this one is radial, this is bearing, this one is bearing. Oops. Bearing inbound to the station. And when do you get the so let's talk about number one aircraft. So this is number one, this is number two. Let's talk about number one aircraft. You will see on your OBS that you are 090. It would show 090. Oops. Let me clean this out right quick. So it will show 090 on top, and you have it centered, the CDI needle. Missing one. And then it will be from, because you're going away from the station, so it's a radial. But if you look at this here, to indication, it will always point toward the station. So in the bottom here will be 270. So if you fly this arrow pointing downward like that, it will be going toward the station. But let's not confuse you guys anymore here. So this is how it should look, okay? And then you're coming back to the station, as this green airplane shows. Let's make it this nav green. So it will. This will show. This will show 270, and this will show centered. And this time it will show this 2 from indication will show 2 to 270. So means you're going inbound to the station. But the only thing that reverse sensing is when you are sitting in this aircraft and flying to the station, but your nav shows 270, and it would show from. And centered. So this is something it's basically it will be like you have to fly away from the needle to catch the needle. That's the only point here. Fly away from the needle to catch the needle. But these ones, you need to catch the needle. Okay? You need to catch the needle. So these are the simple things that you need to know before we move further. Now let's discuss the VOR. Let's again put a VOR here in the middle. VOR DME, let's say. Let's say we are in whatever. Let's see. Let's say we on we are somewhere right here. Doesn't matter anywhere. We're just going away from our airport. Let's say airport was here, and we took off and we going away. We going somewhere. And all of a sudden, ATC comes up and says, "Hey, you got a red alert, something going on ahead of you, restricted area or something, or let's say MOA active." Okay, so they'll say, "Okay, go ahead to Skyhawk. This. Um, please fly heading intercept and track radial of 270 outbound." Let's make it easy for you. Okay, so this radial is 270 outbound. Okay, now what you're gonna do is, number one, we have a formula here. We have to put the formula and use the formula. Number one is parallel the course. The course. Oops. Alright, parallel the course. So we're gonna do our heading. Right now, let's say our heading is basically, heading indicator shows, let's say we are going we're flying 3 300. Okay, we're flying 300, but we need to bring our heading to 20 because number one thing in formula here says parallel the course. So you need to start moving to 270, which is right around here. So we're gonna number one thing is turning to 270. Okay, so we did that. What is number two is tune an ID VOR. Definitely need to tune an ID this VOR. Need to make sure you are on the correct VOR. You're flying correct radial. So you need to tune an ID. There's no way around it. Number three, tune an ID. Basically, what you do is, for whoever doesn't know, is box like that, and you basically put the frequency 108 or something, 0.4, for example, for the page here, and then we would listen for the Morse code. It would say beep beep, something like that, and then that's how you tune an ID. Number three, you need to find your position. Find your position. I don't know if it's even worth it to write down and stuff because it doesn't look like this pencil is too big. Let me see if I can. Okay, find your position. So what you need to do is you need to twist the OBS that you have here. Let's see. So twist your OBS. Let me make it a bit clearer for you guys. Twist. This is even worse. Pencil. Let's try pencil. Alright. Twist the OBS to find your position. So make sure you twist the OBS so it gives you center on this OBS and obviously from. And then take a look what radial is that. So it's probably going to say, let's say, 290. Okay, I don't know what's going on here. Alright, 290. Okay, now you know that you are on 290. Okay, perfect. Now we're gonna, what we're gonna do is figure out how many degrees is offset from radial you're supposed to fly. So you're gonna twist this back to 270 and it's 290, so it's 20 degrees. So now we're gonna do the formula that says find how many degrees difference and then double the difference. Double the difference. Double the difference, which is 40 degrees. 40 degrees. And number 5 is no flying less than 20 degrees. No turning less than, no turning less than 20 degrees or more than 90 degrees. That's number 5. No turning less than 20 degrees. No turning more than 90 degrees. Okay? So we found this 40 degrees different. We have to turn 40 degrees to whichever direction so we can get to our radial. Now, we know that if we twist back to 270 here, if we twist it back to 270, okay, that CDI needle will go to the left. Okay, so now we twist it back to 270 and it's to the left. Now we have to figure which, so CDI is on our left side, so we have to turn 40 degrees to the left. of our heading, whatever heading we are right now at. So our heading is 270. We need to go 40 degrees to the left. So it would be uh, 2, 230. So our heading is supposed to be 230, from 270 to 230 to intercept the radial. Now we're going to turn our heading to 230. So 40 degrees to the left. And we're going to fly, keep flying, and then we will intercept the radial. Once that radial, that CDI moves, um, like once it start moving, once it's right around here, start your turn back to 270. Back to 270 and get that CDI center at 270 and fly that outbound. I hope you guys understood everything here. If not, just rewind the video and rewatch it. That's the only radial outbound. Bearing inbound, I would suggest everyone to what it's very easy. Bearing inbound, you could do basically anywhere you are. You just so for example, if you're right around here, what you do, that's nav right there. That's your nav there, and what you have to do is basically twist the OBS all the way, make it center CDI, make CDI center here, and read the number, what number you need to fly, and then start your turn. For example, you need to go bearing 360, and that's not going to be centered because you're not on a radial of 360, so you have to get to it. It's going to be to the right. As this position says, here is your CDI. You have to turn 45 degrees heading wise to go toward the needle and catch the needle and then fly inbound. Bearing inbound is very easy. Just tune an ID and just fly toward the needle, bring it to center, and fly that heading. Reverse sensing, I have to show you guys on a different app, but that app doesn't work properly right now. It's kind of confusing. You don't have to worry about reverse sensing. Just know that if you're flying, some of the instructors are confused too, like more than half of these instructors. If you are, for example, let's say you are on this radial, okay, your OBS says 180. I'm sorry, let's make it this. So let's say this, okay, you're on 180, okay, and your heading indicator shows you're flying 360, okay, so you're going inbound, and you on the radial, tune the radial here, and that's a reverse sensing, okay, so always pay attention. Just 360s on the other side, just keeps twist the OBS, keep twisting, and they will just transfer to normal position here. Okay, I hope you guys enjoyed the video. Yeah, I'm just have nothing else to add here. I hope you guys understood. If not, then I'll make another video. Alright, see you guys on the next video.